Hello, everybody. Really great to see you all again, and welcome to another Future of Blockchain workshop. And great to see such good attendance for all of these sessions. And I'm really enjoying working alongside you all, seeing all of your questions for all of our speakers. Once again, I don't have too many notifications. I'd love to encourage all of you to reach out either via Discord or Calendly. We do really love hearing about all of your projects, whether you're simply searching for a team, we can obviously help you with that. If you found a team but aren't quite sure which bounties to look at or your project itself, again, we can help. Or even if you've come up with an amazing idea, we would just love to hear about it in general. So do keep in touch. We do really enjoy hearing about what you're all building. But as normal, I will drop all of the links that you will need into the chat so you can access those. And that's about everything from me. So I'm really delighted to welcome Usman back. Usman is from Ava Labs, and he will be providing his workshop today on Avalanche Subnets. So I hope you all really enjoy it. Any questions, please direct them to the question channel, and I will do my best to get those answered for you. And Usman, I'd love to hand over to you to kick things off.
Awesome. Well, thanks so much, Rory, for the awesome intro, and really happy to be here and be a part of another Encode Hackathon. So just awesome to be here. So I'll just go ahead and share my screen and get everything set up for everybody. Perfect. Can you guys see that right there?
Yep, we can see it. Perfect.
Awesome. All right, so just to give you guys a quick intro to myself. So my name is Usman Asim. I am a developer relations engineer at Ava Labs. So we are the company that built the Avalanche blockchain. If you guys are familiar with Avalanche, if you guys are familiar with blockchain in general, that's great. But I've really catered this presentation to be very beginner friendly. So for anyone at any spectrum of the level of blockchain development, welcome. Today, we're going to be talking about Avalanche Subnets, which is a really unique concept and something that we like to consider the future of blockchain development. So let's go ahead and get started. So kicking things off, I know you guys are all participating in a blockchain hackathon, so a lot of you must already be familiar with what a blockchain network is, but I always like to kick things off from first principles just to be able to give everyone a wide understanding. So what is a blockchain network and why is it valuable? So at its base layer, a blockchain is just a ledger or a database that's composed of data in blocks. So what that means is that an amount of data will be put into a certain time allotted block, and then these blocks are securely linked together using something called cryptographic hashes. What's really powerful about this is that this database or ledger is secured by many computers or nodes in a network. So when we talk about really cool, powerful blockchain networks being, censorship resistance or all these really cool, unique attributes that we would like to attribute with blockchains, it's due to this fact that this blockchain is being secured by many, many computers in a network. And so the process of securing the network or the blockchain is done using something called a consensus mechanism. Computer scientists have been studying consensus mechanisms since the inception of distributed systems. So far in the overall computer science and distributed system space, there's been three major advancements of consensus. So one being classical consensus. So this was, if you guys are computer science students, you might be familiar with things like PBFT or other traditional consensus mechanism implementation. So consensus has been a part of computer science for a while, more specifically distributed systems. So what was really powerful with classical consensus was that it introduced this idea of fault tolerance, introduced this idea of many computers being able to communicate with each other. But what was really showcased with classical consensus was this idea that, when many participants need to participate in a network, these classical algorithms cannot handle multiple nodes, and these tend to be very centralized systems due to them having very designated sets of nodes or leaders. So with that came the introduction of Nakamoto consensus. And so this was what was introduced with Bitcoin, which allowed this idea of decentralization, meaning that instead of using a predetermined number of nodes that can be found in classical consensus, in Nakamoto, any node can participate in consensus and validating the network. There was also this idea of incentive-driven security where, validators had to solve cryptographic puzzles to secure the network, and then they were rewarded by doing so. This was given by a civil resistance mechanism called proof of work, which I'm sure we're all familiar with. But what, proof of work has its own problems as well. Being the energy intensiveness and compute intensiveness that it requires just to be able to run a single machine in the network, which also inhibits the ability for that network to scale as well. And so then came the idea of Avalanche consensus. And so Avalanche consensus was built to basically take the best parts of both classical consensus and Nakamoto consensus and combine them to be able to achieve high throughput, fast finality, and energy efficiency. So essentially being able to take all the pros of each consensus mechanism and creating one consensus mechanism that can actually be utilized in a large scale blockchain network. So just to go back to what we were talking about earlier, what is a blockchain network and why is it valuable? A blockchain network is just a ledger that is composed of data in blocks. And these blocks are secured by many computers in the network, and the process to secure those computers is consensus. So a lot of, for folks who are already in the blockchain space or who might already, be very familiar with all this stuff, this is all very, just reminding information. But for folks who are new to the space, this is the real value add that this technology can provide and how it starts at the bottom layer. And so when you think about applications that are built on top of networks like this, you have applications that are now immutable, secure, censorship resistant, and where power is distributed among participants in the network. And so, in traditional technology systems, like we mentioned, power is typically very centralized, very mutable. And then, since power is centralized, that doesn't make for a very secure system. But using blockchain-based systems with high distribution of nodes, you have the power to be able to create a network that's immutable, secure, censorship resistant, and distributed. So that is the basis of the value pitch of what this industry provides. So with that was the introduction of what we like to consider blockchain 1.0, which was Bitcoin. So with the whole great financial crisis that happened in 2008, someone took this concept of a distributed system network and said, hey, let's build out a payment system using it, right? So they saw these values and thought that if we were able to implement this into a payment system, it would be really powerful and better than the system that we have today. And that's where Bitcoin was introduced. So Bitcoin introduced the idea of a peer-to-peer network where folks participating in this network could now transfer value between each other in a completely decentralized and open way. It was very secure using a lot of cryptographic secure mechanisms. There was a lot of initial innovation that came with Bitcoin that was not present within the internet at large. But with any inception of a new technology comes its own downdraws. So Bitcoin as itself, as a network, was very powerful. It embodied all these values that we mentioned earlier. But as the network started to gain popularity and people actually started to use it, we realized that Bitcoin has very slow transaction throughput, meaning that every time a block is mined in Bitcoin, it takes 10 minutes, which limits the number of transactions that can happen per second, which also leads to delays and different timings that it takes to publish a transaction onto the actual blockchain. And so Bitcoin was also a single use case blockchain. So it was designed to be a currency, designed to be a transfer of value. So it was a really powerful inception of the technology, but again, just blockchain 1.0. Then we were introduced to this concept of blockchain 2.0, which was Ethereum. And so Ethereum introduced this whole new idea of smart contracts, which are essentially programmable contracts that can execute automatically, and really introduced this new concept of being able to program money. which was really powerful for new users, for any programmer in general, but for anyone diving into the space of blockchain and crypto, being able to now create applications that utilize these assets in new ways really pioneered new technology. So it was able to do this by using a Turing complete smart contract language using called Solidity, which is built on top of the Ethereum virtual machine. So the Ethereum virtual machine, you can consider it a computer, a decentralized computer that is able to execute these smart contracts that we just mentioned. And so this led to a flurry of applications being born in many different sectors. I'm sure you guys are familiar with decentralized finance, decentralized social, basically being able to create applications that now that embody these values, but at the application layer versus just at the payments layer, which was with Bitcoin. And so this was really powerful, very groundbreaking. And then again, like with any inception of a new technology and any start of a new chapter, there's always drawdown. So when more folks started using Ethereum, as the network traffic started to increase, we saw things such as increased gas fees. We saw things such as the ability for folks to not be able to use the network due to its high usage. And so now we're at a point of the industry where you're starting to see many folks try to pioneer solutions towards this scaling problem within Ethereum. And so whether that's layer twos, whether that's modular blockchain design, whether that's ZK EVMs, there's a whole flurry of new solutions that are trying to solve the issues that were present within Ethereum, but also build upon the principles that were given to them. And so that's where we believe blockchain 3.0 comes in. And we believe that's Avalanche. And so, like we mentioned at the beginning of this presentation, at the base layer of every blockchain is a consensus mechanism. That's how the nodes are being able to validate that blockchain. With Avalanche, we took the primitives a bit further, where we pioneered our own consensus mechanism. Avalanche consensus was studied, and so it was a paper that was introduced by a team called Team Rocket back in 2018, 2019 or so. And so it was a brand new consensus mechanism, which, unlike classical or Nakamoto, it uses a novel mechanism using something called randomized subsampling that basically has the ability to combine the best parts of classical consensus and Nakamoto consensus. And so we'll be delving way deeper into Avalanche consensus from a technical perspective down in the presentation. But just to give you an idea, at the base layer of Avalanche, it's very different from any other blockchain because we utilize our own consensus mechanism. And when it comes to scaling, as we were discussing with Ethereum, so Avalanche allows for this idea of something called a subnetwork. So a subnetwork is essentially a customized a network within the primary network of Avalanche that allows you to launch one or many blockchains that are customized for whatever use case you want. These blockchains can be completely customizable, and you can have complete ownership of your validator sets. And so we'll be delving into all of this later in, but these are all things that were primitives that were introduced on top of Ethereum to solve the issues present with it, and also build forward, right? And so one of Avalanche's other goals is to also be a complete interoperable ecosystem, because if you're allowing for all these blockchains to be able to be created and live within this one network, they should be able to communicate with each other. And because of Avalanche's unique consensus mechanism, you have high throughput and low latency, meaning that you can process thousands of transactions theoretically at scale. And you can also achieve transaction finality, meaning the minute the transaction is sent to the minute it's published in a block with under 1 to 2 seconds. So that is significantly faster than any other blockchain system. We just mentioned that Bitcoin takes 10 minutes per block. Some transactions in other systems can also take, from anywhere from 10, 20 minutes to an hour sometimes. So it's very, very convoluted. But with Avalanche, because of our consensus mechanism, you have the ability to finalize transactions in under 1 second. And we'll jump into exactly how that's possible soon. But also one fact that also gets pretty overlooked is that our consensus mechanism is very environmentally friendly. So this makes us more energy efficient. Also, this is one of the biggest criticisms of blockchain in general from a lot of folks who are not in the space, who get to just see things like Bitcoin and proof of work mechanisms, and they immediately understand that blockchain is energy intensive. But that's one thing that Avalanche consensus does not require. So let's break down Avalanche consensus a bit more. So again, consensus is just getting a group of computers to be able to agree on a piece of data within a blockchain. So Avalanche does this utilizing a process called random subsampling. So instead of every node voting on every transaction, like is in regular blockchains, in Avalanche, a subset of nodes is selected to be able to vote, where one node will ping a subset of other nodes, and then this process will be repeated multiple times until they've built enough confidence in a certain transaction's validity. And so what this allows for is transactions to achieve finality in a matter of seconds, rather than minutes to hours sometimes, right? So this also allows the consensus mechanism to be very lightweight in terms of the energy, in terms of the resource intensivity, like we mentioned earlier. So this makes it energy efficient. But most importantly, it makes it the most robust consensus mechanism out today in terms of finality, speed, and scalability, and also security. So due to the nodes that are malicious being not pinged, or being able to, the confidence is not able to be made with those nodes, it makes it very resistant to common vector attacks that are present with many blockchain systems. So here's a cool little graph that showcases the pluses and minuses of different blockchain-based systems. Obviously, you have the benefits of classical consensus, you have the benefits of Nakamoto consensus, and then you see that Avalanche consensus is a summation of the best qualities of both. And so just to give a little bit deeper insight into that, with traditional mechanisms, the real problem that you really have is with scalability, meaning that you scaling to infinite nodes with classical consensus mechanisms. And then with Nakamoto consensus is that when you scale to that amount of nodes, the network becomes virtually unusable. So with Avalanche consensus, the idea was to be able to scale to infinite amount of nodes and make the network very robust at the same time. So unlike Nakamoto consensus, which is present in Bitcoin, where you need multiple confirmations to basically have a transaction finalized, Avalanche can achieve this in seconds due to random subsampling. Again, it's energy efficient, but most importantly, it's also Avalanche consensus ensures a high degree of decentralization because, again, like classical consensus mechanisms require a set amount of validators, Avalanche consensus allows you to be able to grow to infinite validators. So without sacrificing for any performance. So on top of this, yeah.
Sorry, we've just had a quick question in the chat, which I'll read out for you. It says, could you please give a little more detail around how Avalanche prevents the 51% attacks?
Yeah, of course. So with any blockchain-based networks, 51% attacks are definitely very possible. So if anyone were to gain control over 51% of the nodes in the network, that in any system would be a compromising fact. But due to certain barriers to entry, such as 2,000 AVAX needing to be staked prior to launching a validator, there are certain barriers to entry to just launching a validator that kind of prevent the ease of anyone spinning up a validator, to prevent someone from taking control over the entire network. But those kinds of barriers are put in place to be able to prevent something like that. But again, like any other blockchain-based network, I think that 51% attacks are very possible with anything. But it's highly unlikely. If you look at the distribution of our nodes, it's very distributed. But yeah.
Amazing, thank you. And then we've also had a second one talking about the energy efficiency of Avalanche and whether you have any metrics which you use to kind of measure this efficiency.
Yeah, 100%. So I think one of the key metrics that most folks use to measure energy efficiency is how much kilowatts per hour are utilized by a specific node running, and it's like how many, how per block, how much energy does this actually take? And I think there's a really cool chart on the AVAX website. If I just do it in the chat right there, so you guys can go and look for it. That showcases the differences between the main blockchain networks, the energy efficiency, the energy that they take, and where Avax ranks within that. So all the metrics should be present there.
Great, thank you very much. I'd also encourage any more questions, please do feel free to ask them in the chat, but thank you, Usman.
Definitely. So now that we've I know it's been a lot of information, a lot of dense information up to this point, but a lot of this was majority background information. So we covered what a blockchain network is. We covered how there's securities and consensus mechanisms. We've covered the progression of blockchain from blockchain 1.0 and Bitcoin all the way to the new era of blockchain with Avalanche. And we've discussed Avalanche consensus in a brief way. So on top of that unique and novel consensus mechanism is where our blockchain network was built. And so this is the Avalanche primary network. If you see this visual, it kind of gives you a cool summation of what the network looks like. We're going to be delving a little bit deeper into what this actually means in a bit, but the goal of the primary network is to be the heart of the Avalanche ecosystem. It facilitates the creation and operation of different subnetworks within the Avalanche, within the overall Avalanche network, and the nodes that participate in the primary network can also help secure subnets and validate the entire thing. So this is where the heart of the Avalanche ecosystem lies. So in this, you can see that there's 3 main blockchains. So the Avalanche primary network, you can think of one network composed of 3 main blockchains living in one network. The first blockchain is the X chain, which is the exchange chain. This is where a lot of the bridging is done into external ecosystems. So this blockchain has a very specific use case just to be able to exchange, create assets. Then you have the P chain, which is a blockchain that is completely geared towards managing all the validator sets on Avalanche. So this coordinates the validators, it coordinates the creation of subnets, and has a lot of other validation related logic that's specific to the P chain. And so you can, and then finally you have the C chain, which is an EVM compatible blockchain, which you can basically execute EVM smart contracts on and port over a lot of your code if you're building on any of these other EVM compatible blockchains. So as you can see, in one network, in one subnet, we have 3 main blockchains that have 3 very different purposes that all utilize different consensus protocols as well. So just that off the bat, before we delve into how that's possible, what this means for an overall network, just that on itself should be able to showcase the real diversity and customizability that you have within an Avalanche when you're building within this ecosystem. But today, most dApps live on the C chain. So as we mentioned earlier, the C chain is EVM compatible, and because it utilizes Avalanche consensus, it finalizes EVM transactions in under 1 second. So any other EVM compatible blockchain out there usually typically has many minutes to finality, whereas the C chain is under 1 second instant finality on an EVM transaction. So for most dApps who are launching on Avalanche, they tend to go directly to the C chain because they're, whether they're already in blockchain, they're already deployed on other networks, they want to be able to launch on the EVM, but they want to utilize robust and fast consensus and instant finality. They do that on the C chain. But as is the problem with any other blockchain network, as we mentioned with Ethereum, as projects start to see scale, the overall network becomes more expensive and slow, and rendering the network almost unusable, right? So with that, we have the introduction of this concept called a subnet. So we briefly touched on subnets up to this point, but now we're going to delve a little bit deeper into the real value add of what blockchain-based networks can provide. So again, if anyone has any questions, please feel free to throw them in the chat. I've been going pretty fast here, but I want to make sure that there's no gaps of knowledge. So Avalanche Subnets essentially allow you to launch your own custom blockchain, tailor-made to whatever use case you would like, with fully custom virtual machines, fully custom rule sets, and fully custom validators. So at its base layer, a subnet is just a subset of validators from the Avalanche primary network that validate your own blockchain. And so one of the biggest problems with app chain solutions today, or roll-ups as a service, is that they're usually utilizing only one node, or utilizing, they allow you to launch your own custom blockchain network, but utilizing only one node or one sequencer, or very limited amounts of nodes. So with Avalanche Subnets, because again of the consensus mechanism, you can scale to infinite number of validators within your own blockchain network. So it's a really powerful concept, and giving you the ability to take full control over your validators is very key. So again, with subnets, you can enforce custom rules, ensuring that these blockchains are completely suitable for your specific use case or whatever industry you're a part of, meaning that you can look at your blockchain, say, I can customize my virtual machine, customize how I want this virtual machine to be validated, who can participate in consensus, what geographical locations these validators can be present in. You can customize it from the ground up, which is really, really powerful, and very honestly not found in any other platform, giving you that full range of customizability. So another really powerful concept within subnets is this idea of interoperability. So again, like we mentioned earlier, if you have your own custom blockchain, you have your own custom network, you want that network to be able to communicate with other blockchain networks, to be able to access liquidity on other networks, and not be your own siloed ecosystem. So interoperability is a key part of subnets as well. But again, with full customizability means that you can fully customize the security of your blockchain as well. So you can have your own fully custom model in terms of the validator side, but you can also leverage the security of the Avalanche primary network as well, to make sure that you are also running a very secure network. So there's a huge collection of nodes on the Avalanche primary network. Being able to leverage them is key for your subnet as well. And so this actually ends up creating really interesting subnet economies, where validators are now incentivized to run them, because now you have multiple subnets wanting to come to these validators to validate their subnet. And it's a really interesting rabbit hole to dive down, but we won't go too deep into it. But just something to be aware of. And so what this does is that it powers really diverse use cases, because when you give folks the ability to launch their own fully custom blockchain with fully custom rule sets, that really gives them an open playground to be able to build whatever they want. So on the larger side, we've seen some really, really awesome subnets come out in the recent past couple of months. Few of my favorite. So number one, Intane Markets. So Intane Markets is a fully tokenized structured credit platform, very enterprise institutional kind of vibe to this kind of a platform. Originally was built on Hyperledger, but now is migrating over to a subnet, and has over $4 billion in assets originated. So something like an Intane Markets that is going into very enterprise institutional kind of focus, that's originally built on a monolithic blockchain like a Hyperledger, which is an enterprise blockchain. They need to be able to look at a blockchain network and say, hey, we need full KYC and AML compliance. We need to be able to control our validator sets fully. We need to be able to launch an EVM that has certain changes made to the EVM. So we want to be able to have an allow list within our EVM, so only certain whitelisted addresses can transact. And this is the theme of many institutions who are trying to join the space today who need all these requirements. Because Avalanche is so open and so free for you to build whatever you'd like, you have the ability to build a fully permissioned blockchain that is fully KYC AML compliant, that these institutions and enterprises can leverage. So we have a whole new program called Spruce and Evergreen, which is basically geared towards institutional deployments on blockchain, utilizing a custom version of the EVM that's very permissioned, you could say. And then on the flip side, you have other builders who want to utilize fully decentralized networks, and they want to build fully permissionless applications. So if you look at the bottom, we have a DEX called Dexalot, which is essentially a central limit order book that was initially launched on the C chain, but saw so much success that they wanted to launch on a subnet. They also wanted some certain customizability with their gas fees and certain other really cool things that the C chain they weren't able to get on a base blockchain. And so they launched their own fully permissionless DEX, fully customized to their liking on an Avalanche subnet. So as you can see, you have two ends of the spectrum here, where you have one side where you can launch fully permissioned blockchains because the network is so open and allows you to do so. Then you can launch fully permissionless blockchains because the network is so open and allows you to do so. And so both are possible, and that is, again, a testament to the openness of the consensus mechanism. Another really cool project I'm excited about, I just threw this up here, is Shrapnel. So this is a AAA FPS game. If you're a gamer out there, this is a really well-known team, coming from really, AAA background. But they also need the ability to have custom gas configs. They need to be able to have certain, fee mechanisms that align to their game. And so they need to launch their own custom version of the EVM. And so because of Avalanche, you're allowed to launch an EVM that is customized to your liking. We'll delve into how you can do that in a bit. But this concept of subnets is really, really powerful. And launching custom blockchains is really powerful. And we've only started to see the subnets being built out that are really taking advantage of this full customizability. So I know a lot of this conversation has been how Avalanche is a progression in blockchain, but there's a lot of noise in the space, right? As I'm sure you guys all know, there's a lot of noise. There's a lot of different blockchains out there. So even through this whole conversation up to this point, you might still be thinking, okay, so what? Another scaling solution, another app chain, another L1, what's the point, right? And so if up to this point you haven't been able to get it, Avalanche subnets are much more than a scaling solution. They are a giant umbrella where you can launch your own fully custom blockchain with full customizability baked into the core architecture because of the consensus mechanism, which basically allows you to power any use case imaginable. So we really view ourselves as the ultimate place, the one-stop shop to deploy fully custom blockchains. And that's one thing that we feel has been lacking in the industry overall. But this is, again, we're going to delve a little bit deeper into how you can launch your fully custom blockchain. Number one, the most important thing is that you have full control of your validator sets. So as is any other blockchain network, when you're launching your own network, you want to be able to have full control of how the validators in that network participate in that network. So meaning, how do I want these validators to be geographically located? Do I want them to be set in a certain geographical jurisdiction? Do I want them to be globally distributed? How do I want the security models to be written, right? Validation models. Some are very lenient, some are very stringent. Do I need KYC AML compliance? Do I not? Do I need the ability to only have 20 validators in my network because I want to keep it very concise? Or do I want the ability to have thousands of validators in my network because I want it to be fully open? These are the things that, because of Avalanche consensus, you have the ability to do. And you're really given full control over your validator sets as a subnet operator, which is really, really enticing, not only for large institutions and enterprises who are using this technology, but also everyday users such as you and I who want to launch our own blockchain networks that are permissionless. and allow anyone to participate in them. So that's a really powerful base layer idea that isn't present in many other blockchains. But building upon that, you also have the ability to launch fully custom blockchains, and we'll delve into what that means. So at the blockchains layer, again, like we mentioned, many blockchains today, when they're launching, they utilize the EVM, which was the revolutionary distributed computer that allowed us this idea of smart contracts. And so many platforms nowadays utilize EVM. We have our own instance of the EVM, like we mentioned on the C chain. But with Avalanche, you can create your own custom virtual machine from the ground up. So basically giving you the ability to be able to embed logic that you might be doing at the smart contract layer or overall blockchain logic at your virtual machine layer. And you're given the ability to define that, which is really powerful. And so these custom VMs can actually enforce specific rules or logic that might be necessary for certain applications, and really allow you to build custom blockchains. So we have one team that's building a completely private payment blockchain. It's just one blockchain geared towards payments using ZK. And they were able to utilize the Avalanche's openness to be able to implement these ZK primitives into their own custom blockchain. So it's not EVM, it's not a fork of another virtual machine, but it's its own virtual machine utilizing ZK, facilitated for payments, right? So you can really create new primitives and new applications that many folks cannot today. So and so if you look underneath that description, you can see two of our SDKs that we offer to be able to build this. One of them being the Hyper SDK. So the Hyper SDK is a super highly performant SDK to be able to build super highly performant virtual machines. It's highly opinionated, meaning that it forces you to build in a certain way, but that way is geared towards optimization and towards full speed throughput. We've seen some virtual machines be built with this that can power 30 to 40,000 transactions per second locally, and so you can really build high performant virtual machines using this SDK. And this is what was used to build that ZK payment rails virtual machine. But you can also utilize other SDKs that we offer, such as our Rust SDK, to build fully open virtual machines that aren't as opinionated as, let's say, the Hyper SDK. So really, again, you have the full openness to build whatever you want, and you have the tools at your disposal to be able to build those virtual machines. But we also recognize that many folks who are launching their own custom blockchains don't want to launch a custom virtual machine with logic embedded in the blockchain layer. They just want to be able to leverage existing virtual machines such as the EVM, but be able to modify it to their liking using stateful precompile. So because of Avalanche, so giving you guys a little bit of a background, in Ethereum, precompiles are essentially specific special smart contract addresses that have very specific hard-coded functionalities that are really like computationally intensive, that change the way that, let's say, the EVM functions. So in Avalanche, we have the ability to have something called a stateful precompile, which essentially allows for those contracts to be able to maintain a state across transactions, which is different from Ethereum, where precompiles are stateless. So in Avalanche, you can actually modify the state of a transaction using these precompiles. So that's really powerful because, again, like that allows you to do things like implement an allow list on your EVM that allows you to have certain gas fee configs on your EVM, allows you to mint, different tokens. So there's really essentially launching your own custom version of the EVM. And so we've seen realistically developers who are launching subnets fall into either of these two buckets, where they're either launching a fully custom blockchain that is completely built from the ground up, or using the Hyper SDK that is geared towards or optimized towards their specific use case. Or we're seeing folks launch their own custom EVM blockchain with stateful precompiles with a few things changed in there to be able to fit their use case as well. So again, full control over your validator sets. And now you also have full control over how to build your blockchain. And so putting all this together, you have full interoperability as well. So leveraging something called Avalanche Warp Messaging, which is a cross-chain messaging primitive that basically allows for arbitrary messages to be sent across different blockchains. Utilizing this, you have now a system that is fully connected, where you have all these different blockchains that are not only living in their silos, but also fully interconnected, fully able to transfer assets and value between each other, and leverage each other's security to a certain extent too. So AWM allows for subnet validators to produce something called a BLS multi-signature, which will attest to the validity of any message that is sent from subnet to subnet. Since all these validators also validate the primary network through the P chain, they can access the stake weights of each validator and the BLS public keys of any other subnet to be able to ensure this efficient cross-chain communication. And so this is really foundational for Avalanche subnets as a whole. But realistically, subnets have full autonomy, again, on how they want to utilize this. So if they want to determine that they want to accept messages from certain subnets but not others, they can do that. If they want to determine that they want to have certain requirements for messages to be validated, they can do that as well. So again, keeping the same ideals in place, that Avalanche is an open playground for you to build whatever you want. At the messaging layer, that's no different. You can fully take advantage of Avalanche Warp Messaging in a permissionless way. So this leads me to the end of our presentation to kind of showcase this visual, which is Avalanche, a network of networks. So this was one of the first few visuals that was initially created to showcase the idea of Avalanche, right? Where you have the primary network living in the heart of the ecosystem, have all these subnets that are connected to the primary network, and then you have external bridges to external ecosystems. So this is this was the initial, I guess you could say, graphic, but I want to show you guys something really cool here. So one of the teams building in our ecosystem called Snowpeer, they actually created something to visualize subnets in this way, actually. So if you guys can see that, these are all the mainnet subnets that are live today. So you have at the heart of this the Avalanche primary network, and then you have all these different subnets with one or many blockchains in each, their own custom ecosystems, their own custom blockchains, all connected into the Avalanche primary network and facilitating their own form of transactions. Some of these are games, some of these are financial institutions, some of these are DEXs. It's really wide ranging. And these are just the ones on mainnet. If I were to show you the ones on testnet, you could see the real magnitude of what the potential of Avalanche could look like going forward, right? Where you have many, many subnets all living and connect to this Avalanche primary network, and all able to communicate messages to each other. So I think that does it for me. That is the Avalanche the future of blockchain development presentation. I'd love to hear if you guys have any questions.
Amazing, Usman. Thank you very much. Thank you for sharing that graphic at the end as well. Really impressive to see what could potentially be built. We do actually have a question in the questions channel, which says, does Avalanche incorporate AI yet? Are there any integration mechanisms with existing AI like GPT?
Well, it's an awesome question, right? And so I'll preface it by saying that, I've seen a lot of different AI kinds of solutions being integrated into blockchain up to today, where folks are trying to create GPT plugins, a whole slew of different things to kind of take advantage of this hype cycle. But one thing that I would say that I'm really excited for, or really, I would say proud of, is that our company is very research focused, right? We focus on new primitives, new technological things, pushing things forward. And so that's kind of how Avalanche Consensus was born. So at Avalanche Summit, our CEO, who was the one who wrote the Avalanche Consensus paper, or one of the ones who wrote the Avalanche consensus paper, gave a talk on something called coin-operated agents. So this was kind of a shock to me as well, right? But essentially, and I'll go ahead and send the talk here.
There's nothing holding you back.
Sorry. I'll go ahead and send the talk here in the chat. But essentially, the idea is for in a world where AI agents are able to, generate things, be able, generative AI is so huge right now. We feel they should be able to transact value as well. And so imagine a future where AI agents are now able to transact value to each other, where you can simply say or type, send XYZ amount to this person, and they would be able to send, assets to one another. And so I think this is where the future of this is going, where you have systems that are cryptographically secured by many computers that can send assets to each other, and then you add AI or artificial intelligence into that, and you have a really new ecosystem. So this is something that I would say is a lot more theoretical and really exciting, worth watching the talk. But I know there's a lot of other things that we've done already, where it's like a docs integration with AI, meaning where you can ask, like there's something called Ava GPT, where you can ask questions, and that GPT is trained on our documentation. So kind of just making the developer experience a little bit better. But overall, if you're talking about new primitives, this is something that I would really encourage you to watch.
Yeah, amazing. That looks really interesting. I'm sure lots of people will be watching that, but also great to hear about the innovation going on as well. So lots of questions coming through now. We have another one. How does Avalanche deal with naming services? Is there any integration with ENS, or do you have any native implementation? A really good question, considering some of the bounties that we have in this hackathon.
Yeah, 100%. So currently, ENS is not compatible with Avalanche. We would love to see it, though. But we have our own implementation that a team based in the ecosystem launched. They're called Avi domains. I'll go ahead and send that in here. It's kind of like where you have your .eth name, you have your .avox name, right? And so very similar concept, DID kind of concept. But honestly, if you looked in the hacker pack for Avalanche, a couple of the things that we really would love to see built are some real innovations in the DID space on Avalanche. That doesn't just mean domains, but could really mean anything you'd like. We want to see some innovation in the DID space. Maybe you can leverage an Avi domains. We want to see implementations on the decentralized social level, which could also leverage these domains as well. So it's really open, and we would love to see more things related to this being built.
Amazing. That was going to be one of my next questions, but thank you for clearing that up. Maybe you could provide some tips for people who are looking to build towards those bounties, of where they can get started, and potentially some useful documentation that you might like to point people to.
100%. So we have, again, two main bounties for this hackathon. One of them being launching a use case specific subnet. And what that means is you're able to launch a subnet using our Avalanche CLI, either locally or on Fuji, being able to have it geared towards a specific use case, right? And so we just went through subnets. We just went through the idea of being able to launch a fully custom blockchain. So we would love to see either EVM subnets, or we would love to see custom virtual machines being built using our Hyper SDK. So I'll go ahead and send some resources for you guys in here, but would definitely recommend checking out our Hyper SDK or our Rust SDK, or our precompiled EVM repo, which I'll also send in here as well, because these are all ways that you can launch a fully custom blockchain on Avalanche. And so utilizing Hyper SDK for the custom blockchain side of things, and then utilizing precompiled EVM for launching a custom precompiled based EVM blockchain. So if you want to tackle the custom blockchain subnet bounty, these are the two SDKs or two repos I would definitely take a look at. Please ping me if you have any questions on these. But if you want to tackle the C chain, the C chain bounty, this was one that's going to be a little bit more competitive, where we are going to be really looking for innovation on applications. We're going to be looking for new primitives to be built, whether it's in decentralized social, decentralized ID, innovative DeFi. Obviously, there's a lot of GameFi out there, but we would love to see really realistically new primitives being built. And since this is on the C chain, it is all Solidity. It's all EVM compatible. So launching an app on Avalanche C chain is very similar to launching, or Avalanche Fuji is very similar to launching on any other EVM compatible chain. So we really want to be able to see some technological, EVM kind of innovation there. New projects, new ideas, and hopefully even projects that you might want to continue past this hackathon, right? Those are the kinds of projects we really want to incentivize as well. But definitely on the custom VM side, those two links are your best friend. And then on the EVM side, our documentation has everything you need, which I'll send some links for as well.
Amazing. Thank you very much. We've also had a follow-up from Solomon, who asks if you could talk a little bit more about the Hyper SDK and just generally how it works.
Yeah, 100%. So Hyper SDK is essentially a SDK to deploy highly performant virtual machines. It's all written in Golang. And so if any of you guys have built a blockchain before, which I know there's a range of developers in here, but if you've ever built a blockchain before, if you've ever looked at the low-level technical details present within the EVM, you understand that there's a lot of logic that has to be written in terms of how blocks are produced, how you want gas to be configured, how there's so much logic that you have to create from the ground up that makes it very tough for any developer, especially one who might not be well versed with VM development, to jump in and say, hey, I want to build my own custom blockchain with a custom virtual machine. So if you feel like you are a developer that has the power to do that, our Rust SDK is completely open, completely gives you no starting point, and just gives you a point to just say to build from the ground up. We have virtual machines. We have SDKs like that. But with the Hyper SDK, the idea was to create an SDK that takes a lot of those complexities away from a developer, so that they don't have to worry about a lot of the base level stuff when building a blockchain. They just have to focus on creating their own logic on top of that. And so that's why we say it's highly opinionated as well, where it's geared towards super high throughput applications, geared towards super high throughput. But realistically, you could build whatever virtual machine you want using our regular Go SDK or our Rust SDK. But the Hyper SDK is realistically geared towards super high throughput solutions. So, for example, in the Hyper SDK, I'll go ahead and link it in the chat as well. But if you go into the examples repo, you're going to see one virtual machine that was built with this SDK called the token VM. And so essentially, this was just a proof of concept to showcase the power of the Hyper SDK. So if you're familiar with a traditional DEX, they traditionally have like order books. Or if you're traditional finance, they have order books where orders are matched. Every time someone buys, someone is selling, and vice versa on the other side, right? And usually that's done by smart contracts. But with the token VM, you have the ability to be able to embed all the order book logic, how transactions are done at the virtual machine layer. So really eliminating the need for any smart contract and just embedding all that logic at the base layer of your blockchain. It's really powerful. So this VM was tested to have 30 to 40K TPS. It's really when you have a specific use case that you feel like you don't need the EVM for, but you really want to highly optimize, you can utilize the Hyper SDK.
Amazing. Sounds like a great tool to use. We perhaps have time for one last question. So I'm going to go to Dan, who asks, can you describe in a little more detail about how a subnet inherits security from the main Avalanche network?
Yeah, 100%. So this is a great question. So this is one of the questions that I feel is very important to understanding the value add of of the subnet economy as well. So with Avalanche with any subnet, you have a subset of validators of the primary network. So that means that every subnet that has validators present within it, those validators are also validating the primary network as well. So the overall primary network with the increase of additional subnets, the network of the security of that network innately increases because more validators are validating it. So that's the primary network. But on the flip side, with these subnets that are having their own sets of validators, they can actually leverage the validators that are already validating the primary network to validate their subnet as well. And so what that means is that now you have different blockchains, different subnets launching that can that may need many validators to participate in consensus for them, but they don't have the bandwidth to run those validators themselves, nor do they want to. So they can go to existing validators that are already present within the Avalanche ecosystem and say, hey, would you want to validate our blockchain? And what that does is that those validators now have some sort of model that they can also build a business upon as well. Because if now you have a commodity that is being your validator that is wanting to be utilized from many subnets, you can create a service regarding that too, right? And so we have seen many different platforms within our ecosystem as well try to leverage that and try to create their own subnet economies, being able to leverage different existing validator sets and kind of sharing that security among different validators. But realistically, you can leverage security that from the validators that are present within the primary network fairly easily.
Amazing. Once again, thank you so much. I think that's all we have time for in terms of the questions. If there are any more, I do encourage you to ask those in the Discord channels, and we will do our best to get those answered for you. But Usman, I'd love to say thank you once again. I think that was a really great session. It's really great to you as well to take it back to the first principles and kind of build it up that way. The subnets themselves, great to hear about the power that they kind of hold, and anybody looking to build their projects, they seem like an amazing tool. So yeah, thank you very much for that. To all of our participants, I'd like to mention today's workshops quickly before we leave. So we kick off with Spruce ID and their workshop on using open source to power your app with decentralized identity. That kicks off at 4 p.m. BST UK time, and shortly after at 5:30 p.m. we have an overview of the Arbitrum DAO and how you can get involved. So they should be two amazing sessions yet again, and we do hope that you can join us for those. But before I sign off, I'd just like to say thank you one final time to Usman, and I hope everybody enjoyed the session. See you all tomorrow.
Thanks, everybody.